Okay, 8.2 is about graphing polynomial functions. So, some things that we need to know when it comes to graphing polynomial functions. In order to graph, we need to know, number one, the X-intercepts. After we know these X-intercepts, we want to know the multiplicity right? We want to know the multiplicity of our intercepts, our X-intercepts. We also want to know this end behavior. All right, and then I think the fourth and last thing should be the y-intercepts. All right, so if we know these four things, we should be able to graph our polynomials. So let's take a look at an example. How about we graph h of x equals negative 2x to the fourth plus 3x to the third. So first will be our x intercepts. So remember, we set it equal to 0. All right, and we solve this. This looks like we can factor out a x to the third, or a negative x to the third. All right, divide this by negative x to the third, divide this by negative x to the third. Once again, we're doing it by GCF. So we get 0 equals negative x to the third times, we're left with a 2x minus a 3. All right. From there, we solve each one of these. Negative x to the third equals 0. 2x minus 3 equals 0. This, we'll see, gives us just x to equal 0. Right? We add 3. All right. Divide by 2, so we get x to equal 3 over 2. So that's the x-intercepts. Now we want to find the multiplicity. Second, the multiplicity, right? So of x equals 0, we see that it comes from an x to the power of 3, x to the power of 3. This multiplicity is 3, right? And when the multiplicity is odd, right, it tells us it's going to go through the x-intercept. Our second multiplicity was, our second 0 was x is 3 over 2, and that just came from something that was linear, right? From something that was linear. So this just comes from, right, that comes from, I'm sorry. That comes from 2x minus 3, which has a multiplicity of 1. That, once again, is odd. So because it's odd, it's going to go through the x-intercept. Third step is the end behavior, right? So we have h of x equals negative 2x to the fourth plus 3x to the third, right? We were talking about this last time. This is even, right? This is negative, right? So your end behavior should look something like this. Fourth step now is our y-intercept. Alright, so this time we say y equals negative 2 times 0 to the fourth plus 3 times 0 to the third. So y equals 0. So our x-intercept is 0, 0. Okay, now we can go ahead and graph this, right? So now we can graph. We have 0, 0, our y-intercept. What else did we have as intercepts? This one, right? Remember, this is 0, 0. Excuse me. This is 3 over 2 and 0. Okay, so we have 0, 0. And then we have 3 over 2 is around 1.5. So if this is 1, this is 2. Right in here, we falls are 3 over 2. So we got these points. What was our end behavior? End behavior looks like it's got to go like this. And it's got to go like that. Right? What do we see here? At 0, it's going to go through it with this x to the third. Remember, x to the third kind of looks like that, right? So we come down, we start here, and it's going to go through it. You can see it showing that x to the third characteristic, right? At x is 3 over 2, this is linear, right? So a line goes like that, and it's just going to go through it. So it looks like it's got to come down at some point, go through it. And it just goes like this, right? So it's a little sketch of what this graph should look like. Definitely goes through here, goes through there. At 0, 0 shows the x to the third. At x is 3 over 2, it looks like a line, right? Has that line characteristic. So a nice little sketch of that first example. Let's take a look at our next one. How about we graph f of x equals 2x to the third plus x squared minus 8x minus 4. So we're going to set this equal to 0, right? And because of the fact that it has 4 terms, I'm going to do factor by grouping. Here, GCF is x squared. And we're left with 2 plus 1, or 2x plus 1. Here, GCF is negative 4. Negative 4 comes out, we're left with 2x plus 1. So now we can show it as 2x plus 1. We can show it as x squared minus 4. This can be factored out further, right? X squared equals 0, square root of 4 equals 2. So now this is x minus 2, x plus 2. This is 2x plus 1 equals 0. And we solve each one of these. All right, just like we did before in our factoring chapter. Here we get an answer of negative 1 over 2. Here we get an answer of 2. Here we get an answer of a negative 2. All right, so we get negative 1 over 2 and 0. 2 and 0. Negative 2 and 0. These are all linear, right? So remember, this came from 0 is to x plus 1. Multiplicity is 1, so it's either going to be a line like this or a line like that, and it's going to go through. This one came from 0 equals x minus 2. Multiplicity is 1. So once again, it's either going to be like that or like that. And the same thing with this one. That came from 0 equals x plus 2. Multiplicity is 1, so it's going to go like that or like that. Once again, these all go through. They're going to go through like a line. Right, so this is all step number 1. Oh, and this right here, step number 2. Our problem was f of x equals 2x to the third plus x to the second minus 8x minus 4. Odd, positive, right? So that's going to look something like that. Third step. So now we do y equals 2 times 0 to the third plus 0 squared minus 8 times 0 minus 4. This gives us negative 4. So this is 0, negative 4. Fourth step. Right, now our fifth step is to graph it. Put all this together. 0, negative 4. I'm going to go backwards. And behavior tells us that it's going to be something like this. Our intercepts are, we got negative 1/2, 0. So here is negative 1. That's negative 1/2, 0. 2, 0. All right, 2, 0. And then we got negative 2, 0. So now we have to make it work where it goes through all of this, right? So I'm going to start at this end. It's got to go through like a line. It's got to go through this like a line. All right, it's got to cross the y-intercept, right? Then at some point it's going to go down. We don't know exactly where, but we know it goes down. Then it's going to come up here. And there we go, all right? Nice example. So as you can see, I started with this end behavior. And I know it's got to end over here. So it's again goes through like a line, goes through like a line. It's got to go through the y-intercept, comes down, but then it's got to go up, and it's got to go through this like a line. So there we go. Nice example there. All right. Next example. How about you graph? Let's go with how about we graph g of x equals x to the fourth minus 7x to the third plus 12x squared plus 4x minus 16. And I already factor it for you. The problem tells you that this in factored form is x plus 1, x minus 2 to the power of 2, and x minus 4. Once again, don't worry about how this came about. We'll learn this later. Okay, so we just say 0 equals this. Right, and this is great because it's already in factored form. So here we have x plus 1 equals 0, right? We have this x minus 2 to the power of 2 equals 0. And we have x minus 4 equals 0. Well, this answer is just negative 1. Right? If we work this one out, all right, what can we do here? We learned how to do this last time. We're doing the opposite to what we did last time. All right, so now we're going to take each power to square root, because that and that we learned cancel. X minus 2 equals 0, so here we just get 2. And here we get x to equal 4. All right, so this is a multiplicity of 1. All right. Which means it's going to go through. This one, right, we see this power of 2. Therefore, this has a multiplicity 2. Which means it's either going to go like this or like that. Right? It's going to bounce. Right? Bounce on that 2. And this one, once again, another multiplicity of 1. Just going to go through. So, right, this was kind of our first step, solving. Second step, looking at the multiplicity. End behavior, right? So what do we have? We said it was g of x is x to the 4th minus 7x to the 3rd plus 12x squared plus 4x minus 16. Even. Positive. So we know it's got to be something like that. Third step. Now our fourth step. Make all of our x's 0. So we get what? Negative 16. So we get 0 and negative 16 as our y-intercept. Fifth step, now we can graph. It's going to work backwards. I got 0, negative 16, so that's got to be somewhere down here, right? Third step, we see our end behavior. So it's going to go like this. It's going to go like that. My intercepts, I got negative 1, I got 2, and I got 4. Negative 1, 2, and 4. All right, negative 1, 2, and 4. Okay, so I'm going to start over here at negative 1. It's got to go through it. And it's going to go through it because the multiplicity is 1, like a line. So like that or like that. All right. So I start here. I'm going to go through, right? So kind of fix this up. All right. Let me start this over here. Put it a little closer. So I'm going to go down. All right, go down. It has to touch this x-intercept. That's why I made it look a little closer. Go through the x-intercept, right? So it's got to go like this. Now it's got to come back up, right? When x is 2, it's got to bounce one of these two ways, right? Not go through, but bounce, That's why this multiplicity is so important. So it's going to bounce. Right? And then at 4, it's got to go through once again like a line. Right? So have it come down, and then at some point it comes back up like a line, and there we go. All right, so it's like you're putting these pieces together. Right? So a very nice example. So those are some nice examples of graphing. If you want some more examples, just let me know, and I can put some more up. The last thing we're going to look at here is the intermediate value theorem. So what this intermediate value theorem tells us is that for any polynomial, right, function if give me 1 minute here, y'all. So what it tells us is if we have two different inputs, right? Two different inputs into our function. And these two inputs are opposite signs, then we have a 0 between those two numbers, right? So if P of A and P of B are opposite signs, then the function has a 0 or X-intercept. All right, the function has 0 or X-intercept between A and B. So example, let's use the intermediate value theorem to determine if the function has a 0 between A and B. All right, I say f of x equals x to the third plus x squared minus 6x. And I tell you that A equals -4 and B equals -2. So we just solved this, right? We do f of -4, right, is -4 to the power of 3 plus -4 squared minus 6 times -4. You do this calculation, right? You put that into your calculator, you work it out. -4 to the power of 3 plus -4 to the power of 2 minus 6 times -4. This should give you a -24. You do it again for -2. All right, put all that into your calculator. All right, and be careful. Make sure you're putting parentheses around these negative numbers. Anytime you have a negative number, you always want parentheses when you're using your calculator. And we see that this gives us 8. Since negative 24 and 8 are opposite signs, right? One's a negative and one's a positive. There is a 0 between A and B, right? So there is a 0, right? So this would be yes. How about one more example here? This time I tell you same function, f of x equals x to the third plus x squared minus 6x. I tell you a is negative 1 and b is 3. So we're doing the same thing again, right? Negative 1 to the power of 3 plus negative 1 to the power of 2 minus 6 times negative 1. What do we get when we put that into our calculator? Negative 1, right, to the power of 3 plus a negative 1, right, to the power of 2 minus 6 times a negative 1, right? You do this and you end up getting 6. You do it one more time with your 3. Once again, like I said, it's just some nice problems. All you're doing is really putting this into your calculator and being careful with it, or just following your order of operations. I'm sorry, this here should be a 2. All right. So here we get 18. So since 6 and 18 are not opposite signs, there is not a 0 between A and B. So some nice examples of 8.2. Once again, if you have